This is the crash course in Soh-Cah-Toa. Now, Soh-Cah-Toa is an acronym that stands for sine of theta is equal to the opposite over the hypotenuse, cosine of theta is equal to the adjacent over hypotenuse, and tangent of theta is equal to opposite over the adjacent. Now, this is very useful when you are dealing with right triangles. All right, so I have these labeled sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent, but they are in their written out forms below. So let's go ahead and get a right triangle here. Right triangles are very useful because you can basically break anything down into some right triangles and solve specific quantities. Now with right triangles, we usually get the legs and the hypotenuse. We label them with variables a, b, and c. Now this comes from Pythagorean's theorem, a squared plus b squared, the legs added together, is equal to the hypotenuse, c squared. You can always tell which side is c, or the hypotenuse, because it is going to be the longest side. So if this triangle was upside down or right side left or whatever, the longest side is always going to be the hypotenuse that we will label C for this demonstration. A and B in Pythagorean's theorem are the legs, and they can be interchanged right and left, doesn't really matter, as long as they are the legs. Okay, so for Soh-Cah-Toa, if we were trying to set this up to make sense, we are going to do we'll go ahead and just write this out. So sine of theta, or angle theta, is going to be equal to the opposite. Now, a good way to figure out which side is opposite is if you go ahead and just draw yourself as the angle theta. So that is you, and you're happy because you're doing geometry. You may not be happy, but I'm going to draw you happy. All right, so opposite you, that is where you are looking. When you are looking opposite you, it is going to be across, and it is going to be B. All right, so it's going to be B, and it is across from you. So sine of theta is across from you, and that is going to be, in our demonstration, B. All right, so B, and then divided by the hypotenuse. Now the hypotenuse, as we said earlier, is always going to be the longest side, and here it is C. It is C. So sine of theta is equal to B over C, the opposite over the hypotenuse. So we can go ahead and now do cosine of theta. Now cosine of theta, again, you are still this angle theta, and you are very, very happy. Cosine of theta is going to be equal to the adjacent. Adjacent is the one next to. So if you are this angle right here, and there are two sides that are adjacent to you or right next to you, that is the leg A and the hypotenuse C. Well, we have labeled hypotenuse right here and here, so that is not what we are looking for. This one would be A. Cosine of theta is the adjacent or next to you, A, divided by the hypotenuse, which is C. All right, so now tangent of theta. Tangent of theta is going to be equal to, opposite, which again is B, over the adjacent, and adjacent was A. So as you can see, this can look very confusing, but when you're trying to solve for specific values, and when you have specific values, you can solve for either of them. So I'm going to go ahead and erase this, and we will go ahead and do an example with some real numbers, something that you can hold on to. All right, so let's assume that we have a triangle, and this triangle has a hypotenuse of 5. We know that this hypotenuse is length 5. It could be 5 inches, 5 miles, 5 furlongs. It doesn't really matter as long as we know that it is the unit 5. And the other thing we know is that theta in our case, we are going to make 32 degrees. So we know that this hypotenuse is 5, and we know our theta is 32 degrees. And we're trying to find out how far is this leg, which I'm going to label x. How long is x? Well, the first thing we're going to do is we're going to look at what we have and what we need and see which one of these applies. So we have our hypotenuse. So we're going to look up here and we're going to look at each of these equations and see which ones have the hypotenuse. So sine of theta is equal to opposite over hypotenuse. That is good. We have the hypotenuse. So sine of theta might work. Cosine of theta is equal to adjacent over the hypotenuse. That's good. That one might work. Tangent of theta is equal to opposite over adjacent. Neither of these are the hypotenuse, which is what we have. So this isn't quite going to help us out. The other one we want to look at is what side are we trying to figure out? So we're trying to figure out the adjacent. Again, if this is you, that's you. Adjacent is the one we're trying to figure out. So not only do we need the hypotenuse, but we also need the one that has adjacent. So cosine has the adjacent and the hypotenuse. If we look at sine, it has the opposite. We don't know what that is. We could figure that out with sine, but that would make it take us a little bit longer to find out what x is. So we're going to go ahead and use cosine. All right, so I will write it out. Cosine of our angle. Our angle is 32 degrees. So we're going to go ahead and write that in here. 32 degrees is going to be equal to our adjacent, which is x. That's the one we're trying to find. So we're going to use the variable x as a placeholder. So cosine of 32 degrees is equal to x, which is our adjacent, divided by 5, our hypotenuse. All right, so this is a good equation because there is only one variable and we have an equal sign, so we can figure out what that variable is. So with common algebra, we're going to multiply by 5 on both sides to clean it up, get x by itself. And when we do that, these 5's cancel out. But this side, the 5 remains there. All right, so we will keep that 5. So 5 times cosine of 32 degrees is equal to x. Well, that's equal to x. So what we're going to do is we're going to plug this equation into our calculator. So in your calculator, you will see a cos and then an open parenthesis in which you can type in 32. You need to make sure that your calculator is in degrees for this scenario, not radians. You can go into the mode function and make sure that it's in degrees. So you're going to do 5 times cosine of 32. You're going to make sure that you close the parenthesis. The parentheses are very important because if you don't close the parenthesis, then you might do, if you did cosine of 32 times 5, you could easily accidentally put it in there as cosine of 325 degrees. So make sure you close the parenthesis around the 32. So this will give you, after you hit enter, this will give you a measurement of 4.24. Now I'm going to go ahead and round to the hundredths place. It's actually much longer than this, but it's rounding to the hundredth place gives you 4.24. So we know for a fact that this is not x anymore. We can go ahead and write 4.24. So what does that mean? That means that if our hypotenuse, our longest side right here, if that is 5 inches or 5 miles or 5 light years or whatever it is, then this side, the bottom side right here, is going to in fact be 4.24 inches or miles or light years or furlongs or whatever unit you're in, meters. That's how long it's going to be. All right, so what if instead of this side, the adjacent side, what if we needed to find out what y is? So I'm going to go ahead and change colors. So what if we wanted to find out y? We're trying to find out what y is. Well, in order to find y, we need to use a different one. So we can use sine. Sine is opposite, and that is what y is. Y is opposite of the angle. We can use sine. We also have the hypotenuse, which is 5. That's good to go. We could also use tangent. Now, tangent of theta is equal to the opposite over the adjacent. And we just found the adjacent. The adjacent is 4.24, so then we can use that as the adjacent and tangent to find what the opposite is. I'm going to go ahead and use sine. Right now, I'm going to go ahead and use sine. So let's try this out. So sine of 32 degrees is equal to the opposite, which is y, divided by the hypotenuse, which is 5. So just like cosine, we can multiply by 5 on both sides. And when we multiply by 5 on both sides, we get 5 times sine of 32 degrees is equal to y, because these 5s cancel out and become 1. Good. Okay, so if we were to plug this one in our calculator, instead of typing in cosine, we're typing in sine here. So 5 times sine of 32 degrees is going to give you, it's going to be equal to 2.65. Again, I'm rounding to the hundredths place. So we know, in fact, 100% that this y is not really an arbitrary number, but it really is, in fact, 2.65. All right, we're done. We have, for the most part, solved the triangle. The only missing thing that we're missing from the triangle is this angle, but we don't quite need that right now. Okay, so what if we were trying to find out what the angle was? What is this angle 32? All right, so assuming that we didn't know that this is 32 degrees, we don't know what that angle is. And this is what we have. We have these answers. We can use the Soh-Cah-Toa to figure out what that angle is. The way we're going to do that is we're going to do what is called the inverse of Soh-Cah-Toa. So what that means is all of these will work, and when you're trying to find the angle theta, I'm going to go ahead and use tangent for this demonstration. That way we can get all of these in here. I'm going to use tangent. So how tangent of theta is equal to opposite over adjacent, we can say that theta is equal to inverse tangent. And the way that we show inverse tangent, it was put a -1 of the opposite over the adjacent. All right, so theta is going to be equal to the inverse tangent of opposite over the adjacent. So if we were to write this out, we would have theta is equal to the inverse tangent, -1, of our opposite is 2.65. So I'm going to go ahead and write 2.65 in here, divided by our adjacent is 4.24. 4.24. So the inverse tangent is equal of 2.65 divided by 4.24 is going to be equal to our theta. If you take 2.65 and you divide 4.24, you get 0.625. So the inverse tangent of 0.625 is going to equal our theta. So the inverse tangent, where do you find that on your calculator? So where it says tangent on your calculator, T-A-N, and then open and close parenthesis, or it might not even have the parentheses. If you look above it, you will see tan to the -1. That is the inverse tangent. You're reversing the process. You're going to hit shift, and then the tan, which would be the tan inverse 1. You should see that on your calculator. And then 0.625, you hit enter, and it will give you something very, very close to 32 degrees. When you round it, it should be 32 degrees. And that's it. That's everything. That's all you really need to know about Soh-Cah-Toa.